Hello, everybody, and welcome back to DJ Tutorials. This is step 9 of our geometric composition, and this one is going to be going over how to convert from cycles over to AMD Radeon's ProRender. I would recommend that you go back and you watch step 8 if you haven't yet, so that you have the same setup for cycles as I do. So before we begin, what you'll want to do is you'll want to make sure that you go onto the ProRender website and download the add-on. I cover this in my ProRender crash course video, which you can feel free to watch. I'll put a card up right now so you can go to that if you'd like. But basically, what you want to do, you want to click on whichever version you have, download the zip file, and you'll install it as you would any other zip installer for Blender. And make sure that you read the release notes to make sure you have the type of GPU and system that they recommend to be used for this particular render engine. And you'll want to make sure that you also have installed the material library for Windows if you haven't, just to make sure you've done that, or whatever operating system that you use. Make sure that you have that installed as well. So we're going to jump into Blender, and basically what we're going to do is we're going to sort of handle this methodically from beginning to end. And I have done a couple videos on transferring your file over to AMD or Radeon's ProRender, but this one's going to be very specific for beginners and about how to do that for this specific scene and to kind of talk about some of the nuances. So what we're going to do is we're going to start by changing the render setting. So if you go to your render properties, go to render engine, and you should see the Radeon ProRender selection here. And there's a lot of things that change. Again, I go over this in detail in my crash course for beginners, but I'm going to make things very simple for everybody. If you want to separate your final render devices, which I've done here, and the viewport, you can click this checkbox here. And if you're going to do this, make sure that you only have one render device chosen for your viewport. It just seems to work a lot faster. And for your final render, you can use two if you'd like. I would recommend starting with one and then seeing the differences between adding a second one, especially for animations. It seems like having separate files rendering on two different render devices seems to work a lot faster, but that's something that you can play with. We're not going to deal with sampling at the moment, and we're just going to turn these off, and I'm going to talk about the environment lighting. Now, what you'll want to do is you want to kind of to match cycles a little bit closer. You're going to want to make sure that you choose the same HDRI background. So just really quick, the IBL right here, image-based lighting, is what that means. This is their way of doing HDRI images or environment lights. All you do is you go here to open, go to where your HDRI is. We're using the small studio. Change the intensity to a 0.2, and that's basically going to be it. If you just go right into looking at the rendered view here without changing this, it's just going to set a regular color to the background, which is fine if that's what you're using, but as I say, often you want to use this HDR background for an environment texture to get the best out of your materials and your scene. Now, if you did change the rotation of anything like the z-axis or any of this other stuff, you could do that by taking the gizmo here and changing that, but we're not going to be dealing with any of this stuff here. All we're doing is changing this to the IBL environment texture here. The next thing that we're going to do is we're going to deal with the lighting. If we take it from here and look at this through the rendered view, you'll see that we have the environment light in here, but our IES lights aren't really doing anything. And if I turn them off and turn them on, you can see that there's not really much changing. And that's because how ProRender handles the lights is quite different. And what we're going to do is we're just going to turn off the environment light that we just put in there. So where it says intensity, just put this down to a 0. And then we're going to hit the little eyeball on the fill and the rim lights, and we're just going to focus on this key light here. You can see up here that I still have the node graph open for the black body temperature and the IES texture for the emission that we created in the cycles render engine version of this, but you can see that's not really doing anything. And that's because how they handle in the Radeon ProRender engine, how they handle this is through this tab. So if you go to the Object Data Properties, and then if you still have it on point, which is what we did before, we set this all up as a point light for the IES texture to work. What you want to do is you want to actually go here where it says open. And I'm going to look closely at this to see which texture we used, which is the 3-lobe umbrella. Go over here, hit open, go to my IES textures, and you'll notice that the difference here between Radeon ProRender and Cycles is that it doesn't show the little image next to it, which kind of isn't great because you can't see what the preview is going to look like, but it is what it is. And if we go to the 3-lobe here, where is that? There we go. When it's selected, you can see that now we have a lighting texture in there, but it's really intense. And from what I can tell, the best thing to do with this is to divide the power by 10. And usually that will set up more or less, more kind of accurately what was seen in the Cycles version. You may have to have your final renders or have two different sessions of Blender open at the same time if you're trying to do an exact one-to-one comparison, which is tedious. I do it for my comparison videos, or at least I try to, and it is very annoying. So I don't recommend it. What I would recommend to you is play with the units and see where you like it. So now that we have the key light done, we're going to turn that off, turn on the fill light, and then what we used here is the cylinder narrow. Go into open, we will find cylinder narrow, and then divide that by 10. Turn that off, go to the rim light. We used the 3-lobe umbrella for the rim light here, so we're going to go to open, find the 3-lobe umbrella here. Oops. And then divide this by 10. And that's roughly, or at least should be roughly what we did for the lights. The last thing that we're going to deal with on these IES lights, which I skipped, is we're going to be mimicking the black body temperature for the color that we did in Cycles. So over here, how they do this is you can change the color, but you can also use a temperature, and that's basically the same thing as the black body here. So we're going to click to use the temperature, and we're going to change these all to 5500. I'm going to turn all of these on and go to each one of these, click the use temperature, and then type in 5500 for our light color, or the temperature at least. It's called in quote temperature, but really it's using the black body temperatures to create the light. So again, just to kind of show you what I'm talking about, if I take the key light here and I put this at a 1000, you can see that now it's orange. Okay. Let's just put that back. All right, now the major difference that you're going to see right now as far as the lighting is concerned, we're going to get to the textures in a moment, is that if you look very closely here, you can see that the shadows are very, very sharp. And they're not soft like they were in Cycles. The reason why is that the point light and the spotlight in Radeon ProRender, at least for now, don't really support what's called soft shadows. So if that's a problem for you and you still want to use ProRender because it does end up speeding up your rendering process by quite a bit, you can use the area lights, which function a little bit different, and I go over that in a recent video about how to convert a more complex file over to Radeon ProRender. You're more than welcome to try and use those instead of the IES textures, but that's really up to you. So now we are ready to change up the materials and convert it over from Cycles to Radeon ProRender. So first we're going to head over to the shading tab here, and it will automatically start up in the preview mode. So make sure that you change from the materials preview over to the rendered view, because that will actually show the lighting in our scene. And make sure that you have your environment light set to a 0.2. And what we're going to do is we're just going to start with our cube here. And I'm going to select it and zero in on it. And we're going to do a couple steps, and I'm going to show you how to basically convert this one material. And then for everything else, the sphere, the background, the cylinder, the cone, everything else will be the same, and I'll just speed those up. So the first thing that we're going to do before we do anything is make sure over here on the right that you have the Materials Properties tab open. And what you're going to do is you're going to check this image texture right here. And we are going to change this from non-color, where it says color space here, to sRGB. And you'll see that it kind of does that for all of our materials. At least in my session, that was set to non-color, and it was kind of making all of the materials very, very dull. And if you see this 4 here, that means that's being used 4 times. And this particular image texture is being used on all of these materials. So that's why you're seeing that 4 there. So if you're following along with me and you're doing it exactly the way that I've been doing it, that's what you'll notice. And you'll want to make sure that you change that color space to sRGB before doing anything else. And basically from this point, you could do a render because it has done a straight conversion, at least for the materials in the scene. It's using the cycles principled BSDF that's already built into the cycles renderer, and it does work with ProRender. But we're going to actually transfer or convert this over to using the Radeon ProRender materials shading system because I think that it yields much better results. So make sure that you have the cube selected here. Click on the principled BSDF, and then over here, make sure that Materials Properties is open. Click the Convert Principled to Uber. And what that will do is it will automatically create this RPR Uber node. And what we can do from here is go up to the principled BSDF, select it, delete it, and then work from here. Now, how the RPR Uber node works is that it basically has all these different shaders. And when we do that conversion, it basically reads the BSDF node and then changes it to the proper shaders for this Uber node. In this Uber node, we actually have a way to do this setup that we were doing here, where we were creating that layer weight to control how shiny the object is from different angles. So we're actually going to delete the layer weight, the invert, and the multiply, and we're going to take the image texture uh, output here, make sure that it's in our color ramp, and then you're going to go over here and change where it says metalness right here for the reflection. This is basically what's governing how it reflects. You're going to change that to IOR. And that will basically create an index of refraction for the reflection. And you can kind of see it here. There is a bit of the shininess there, but it's going to a black, and that has to do with the fact that our environment is a dark sort of color. But to sort of like show how this works a little bit easier, we're going to take this reflection color here. I'm going to change this to a white color. And that you can see, you can actually notice where those reflections are on the object. And if you look at this from all the angles here, you can see that the edge gets very, very, very bright and shiny at all of those edges. More shiny as it's more angled, and then more or less shiny as you are flat to that object. And you can actually change this reflection IOR, and I'm just going to change this index of refraction to a 2.1 because I kind of like how it looks on these objects, but you can play with that and set it how you'd like. And then the other thing that we need to do here is that this color ramp was governing our specularity. So you need to take that color and you need to put into this thing right here that's called reflection weight. And then that is going to control basically the specularity for that object. I'm just going to zoom around a bit so you can see how that works. And if you'd like this reflection color here, you could change this to like a yellow or a green or whatever you'd like if you wanted to do that. And you can see here that it is controlling how the color of that reflection is treated. But because it's a little bit more, realistic to have this be a white color or a lighter red, I'm just going to leave it like that. And basically, that's going to be it for our conversion here. It's very simple since we have a very simple setup. You could change the bump map if you'd like. You can change your color ramps to make it look a little bit different if you'd like. It's really up to you on how you want to treat this. And what we're going to do here now is I'm just going to speed up the footage so you can see me basically doing that conversion to all these other ones here. I guess I'll do the ball first really kind of quickly and explain it to you. And then the other ones I'm going to do sped up without any audio. So click on the ball here. I'm going to turn on the overlays so you can see that it's selected. Click principled BSDF here. Click this right here that says convert principled to Uber. Delete this because we don't need it anymore. Take the color ramp from here, put it into the reflection weight, delete the multiply, the invert, and the layer weight, and take this image texture and pipe it directly, pipe it directly into this color ramp here. Then reflection color, change that to a white, and then the right here, metalness, change to IOR, and the reflection IOR, I'm going to make this as well a 2.1. And you're going to basically rinse and repeat for all of the other materials in your scene. And I'm going to speed up the footage here without any audio so you can just watch me do it super quick. Okay, so there we have it. We have our fully converted scene with our HDRI image background. We have set the IES textures here, and we have our materials all converted over to Radeon ProRender. So the next step here is we're going to do some render settings. So go to your render properties. And I'm not going to explain everything in super detail here. It's going to be a little bit of a follow just what I'm doing at the moment just to get your render going. If you would like to know more in detail of what I'm doing, you can watch my crash course for Radeon ProRender. So we're going to go here into, first we're going to go into the sampling. And you're going to set the minimum samples to 64. And the max here, we're going to change to 256. Noise threshold, just leave that as it is. And then for the samples per view update, I will tell you what this does. Basically, when you render out your scene, it's going to show every time that it runs a pass. So every time there's 4 render passes, it's going to show you what that looks like. And it's nice so that you can kind of see what it looks like as you're rendering, but it slows everything down because it will make your GPU kind of like stop rendering, show you the image after it compiles it, and then it starts the render for that next sample. So if you just want to see how things are looking, you can change this to a 4, you can change it to a 1, you can change it to a 10, whatever works for you just to see how many samples you may need for your final. But since we know we're going to do 256 for our max samples, we're just going to change this to 256. There's a caveat here. If you change this to 256, you will not be able to hit escape to cancel your render until it's done, until this set of samples is done. So basically, whatever you set this to, if it's a 4 or 1 and you hit escape, it will allow you to cancel after that number of samples is done. And since we're setting this to 256, it will not allow us to cancel until after the samples are completely done. So all 256. What this will do is it will overall speed up our final render so that we don't have time wasted for it to compile the image. So it will work for what we're trying to do. The next thing I'm going to recommend before we really get started here, if you go to quality, you want to change this max ray depth, change this to a total of 12, change the diffuse to 12, change the glossy, and the glossy refraction to 12, and the shadows, let's also change that to 12. And then to make this, we're not going to look at pixel filter here. Right here where it says clamping, in order for this to look more like what cycles renders out as far as the brightness of the image, change your clamp radiance to 10. The last thing I'm going to recommend is after you run your render, if you find that there are weird artifacts or weird things happening with your final render, if you're using more than one render device for your final image, change it to just using one, and it will usually solve that issue. It does suck because you basically won't be able to use both of your render devices for the single image, but it just is what it is with this render engine. It's a bug right now, and I know that they are working on fixing that. So without further ado, let's go ahead and kick out our render. You can go up here to render and then select this here, or you can simply press F12 to begin your render. Okay, so there we go. We have our final render here. And pretty much from here, you can go up and go image, save as. And just a reminder to anybody, or just to let you know, in your compositing tab, make sure that you don't have a denoiser here from cycles if you tried to use a denoiser or anything like that, because it will not work with Radeon ProRender in the same way. There is a way to get it to work, but I'm not going to go over that in this tutorial. And from there, basically, as long as your compositing is all set up and everything, you should have a very nice final render that you can save out, and that will finish up this image for a very nice professional rendering using Radeon ProRender that you could use if you'd like in your portfolio. I hope you all learned a lot, learned about different engines, and you can now make a decision about which way you want to go at the beginning of a project on what kind of engine you would like to use based on the ease of the node structures or how it's rendering or the speed or whatever it is that you're going to be creating. Feel free to leave comments and suggestions or what you'd like to see in the future in the comments below. And I look forward to seeing you guys then.